And, you know, in 4-3, they were homogeneous, so that it equaled 0, and we figured out how to do that. And then we jumped up to 4-4, where they were non-homogeneous. And then the method was, you do the homogeneous version anyway. So you can almost skip 4-3 and go to 4-4. You get 4-3 practice when you're in 4-4, sort of. Whatever. You might need as much practice as you can get. But I might just come up with an idea that didn't pop up last week. So here, this might be a new idea right off the bat here for you. Let me see here. Hold on, I'm sorry. I'm getting there though. I'm getting there. Alright, this is a good problem. We may run into some ideas. So, it's been a long weekend. I taught you last week sort of how to solve these. What I said is that the general solution y is made up of a yc and a yp. And we start by trying to find the yc, and you find the yc by pretending this is homogeneous. And if you pretend it is homogeneous, then you're pretending it equals 0, and you go through those motions, which means you write the auxiliary equation. You got these constant coefficients. You write your auxiliary equation. You try to find the roots of this polynomial. I think this one factors pretty nicely. M plus 2 and m plus 1. So my roots are -2 and -1. You guys doing okay? And if it was a homogeneous problem where this equaled 0, we'd practically be finished. The answer is, well, so what we call the yc here, the yc is this answer, which is c1 e to the -2t plus c2 e to the -t. We get these two real roots, and this is how you write the answer when you have two real roots. I guess I am using t as the independent variable instead of x. Any questions? You guys okay? Pretty basic stuff. Hey, and now though, what was getting a little weird, and we did 2 or 3 examples, is now to finish this non-homogeneous version of this problem, we make a guess for what we call the YP. And what we do is we guess something that's similar to this right-hand side. Now, I would look at that right-hand side, and I would say that's a linear function times an e function. I think last week I did one that just had a number times an e function, and we guessed a number times an e function. We guessed an a, but this one has this. It has this at, or this, and what you want to do. This is interesting. You want to generalize it to a general linear function times this e function. So your guess is this: at plus b times e to the -2t. You got to do a lot of problems, and we'll get good at this guessing. But this guessing is the part that you do need to kind of get good at. You know, what's funny is you make these general guesses, but there are some specifics. In other words, I wasn't guessing just any e function. Specifically, it was an e to the -2t. But the coefficient in front, I generalized to a general linear function. Now here's the other thing, and this didn't pop up last week, but here it is right off the bat, because I don't mess around. You know, this YP, you know, in the end, we're going to have we're going to write our answer. We're going to write Y equals, and we'll write YC and YP. Listen, so we can't have, this YP better not have any terms that are linearly dependent on any of these terms. You know, these are both independent terms. They're linearly independent. This is supposed to be independent. And then this YP that we're going to add on the end of this, it has to be linearly independent. It can't have any dependent terms. Does it? It does, yeah. What I got over here is a constant times e to the negative 2t. Over here, I have a constant times e to the negative 2t. So that's dependency. And you have to recognize that, and before you proceed, you have to fix that. You have to adjust your YP to fix the dependency issue. So you know how you do that? To make him independent, to make him different, and to make him independent, you multiply by an x. But not x, t in this.
Oh, yeah.
Yeah, but you multiply by a t. Now watch this. If I did multiply by a t to make him independent, that's awesome. Now he's independent from him because he's a t e to the negative 2t instead of a constant e to the negative 2t. But guess what just happened?
No.
Now he's dependent on this dude. So I have to multiply all this by t. It makes him t, and it makes him t squared. So that's my adjusted YP, and that's the official YP. My initial guess was based on what it looked like. My initial guess, I wouldn't have guessed a quadratic. No, it's a linear function times an e to the negative 2t. But because I saw dependency in the YC, I had to make that adjustment. And the adjustment is called multiply by a t and makes it independent. It's tricky, kind of tricky. Maybe we need 3 weeks on this. No. But we need a couple days. Listen, I'm going to make a little note here on my, I'm saying, what am I saying? I'm going to say, I had to adjust my YP because of dependency in the YC. Now we should do more examples of this to see, because there's different scenarios on how this pops up. To actually finish this problem, though, I do have my work cut out for me, kind of. I got to find A and B. I don't know if you remember the procedure. Do you remember what to do? We're calling this Y. It's YP, but it's a guess at a solution here. In other words, if I plugged it in, it should sort of work, which means if I'm going to plug it in, I need Y prime and I need Y double prime. And then I can sort of plug it all in, and I can go through the motions of trying to find my unknown A and B. It's a hell of a process. And one thing that makes it a hell of a process is I got major product rule action going on here. Okay, let's proceed. But there was this new idea about adjusting the YP because of dependency in the YC. So hopefully you caught that, but if you didn't, we'll get more to it. We need a derivative, though. We need a Y prime. Okay, product rule, huh? Derivative of the first. 2at plus b times e to the negative 2t plus, write down the first, at squared plus bt, and now take the derivative of that second guy, which is just an e to the negative 2t, but it does spit out a negative 2. I need a second derivative. A second derivative would require another product rule, actually 2 product rules. Or if you felt like it, watch this. Maybe this saves a little time, maybe it doesn't. But you can do if you wanted to, you could do a little cleaning before you do the next derivative. You could factor out an e to the negative 2t. You'd be left with 2at plus b plus, if you don't mind, I'm going to take the negative 2 and distribute through here. Negative 2at squared, negative 2bt. You see what I did? I factored the e out, and that's what's left. Now, when I go do my second derivative, it's just 1 product rule instead of 2 product rules, but it's a hell of a product rule is what it is. You guys with me? Mm-hmm. All right, y double prime. y double prime is the derivative of the first, negative 2 e to the negative 2t, times this. Holy crap. All right. Turn your paper sideways. I forgot to tell you. Turn your paper sideways. Plus, I'm going to go below it here if you don't mind. Plus, what am I doing now? Write down the first, and take the derivative of this second thing here. The derivative of this second thing would be a 2a. That would go away. Negative 4at. And a negative 2b. Are you guys all right? I got my big old second derivative there. Hang on. My big old second derivative. My first derivative is really right here. And my original function is right here. Do you remember what we do now? We sort of plug them all in. Now, I've learned, I got a little shorthand way of doing that, a shortcut way of doing that I want to teach you, just to save me some writing. So I'm plugging all these in. This y double prime goes in there, and then I have 3 of these y primes, that goes there, and then I have 2 of these original y's. Listen, here's what I like to do. I sort of like to say all that without actually writing. I don't want to write that long, you know, so I'm thinking that and not writing that. So what I have is I have 1 of these y primes. I have positive 3 of these things, 3 multiplied by this crap, and then 2 multiplied by this thing. Right, you guys? Yep. And what I want to do is I want to I'm looking for these coefficients, a and b, and so what I want to do is equate the coefficients of the like terms. Now, what kind of terms do you have over here on the right-hand side? What kind of terms do you have over on that right-hand side? I would call those t e to the negative 2t's. That's what you got over there. That's what they are. That's the type of term they are over on the right-hand side. So now, on the right-hand side over here, how many of those do you have? 4. You got 4 of them. On the left-hand side, you got this plus this plus this. Right, you guys? So let's find all those t e to the negative 2t's. Where are they? T e to the negative, Jesus. Here's one. You guys see it? Mm-hmm. I would call that a negative 4a. See that negative 2? Mm-hmm. I'm going to write that down. Negative 4a. Let's see, you got any more of these things? Just a t. Oh, here's one. That would be a positive 4b. Positive 4b. Here's one down here with a t e to the negative 2. So here's another negative 4a. Another negative 4a. I'm just going to stack it like this. They're all added together if you don't mind. All right, plus here. Plus 3 of these dudes. You see any t e to the negative 2t's in here?
Yes.
There's 2a times 3, so 6a. So now I got 6a. and there's negative 2b, right, you guys? Well, times 3 would be negative 6b. All right, this is fun. What else I got? Oh, up here. I got 2 of these. And I'm looking for the t e to the negative 2t's, which would be 2b, positive 2b. So, you know, I could have wrote that all in a long string, but I didn't leave myself enough room. That's all added together in a long string, and it equals 4. Well, I'll be darned. Check out those b's. Those b's all cancel away, don't they? And I'm left with negative 8a plus, I'm left with a negative 2a equals 4. That's awesome. Guess what a is? Negative 2. You guys cool?
What about the t squares?
Well, okay, what am I looking for, by the way? I'm looking for A and B. So, I'm not done yet. I got A. And I got that A. I didn't know what I was going to get. What I decided to do was look at the t e to the negative 2t terms. Because they were over there on the right-hand side. But there's other terms I can look for, even though they're not on the right-hand side. There's other terms in here. You're right. What else is in here? There's t squared. e to the negative 2t's. Maybe I should look for all those. You're right. And what else?
E to the negative 2.
Just, so I got the t, I got the t squared, and then you're saying just the number e to the negative 2t. Yeah, I could look at those too, maybe. Let's start with these though first. Let's look for all these guys. All the t squared e to the negative 2t's on this left-hand side would come from one of these second derivatives, 3 of these first derivatives, and 2 of these. Let's see what we got. And here they are.
Positive 4a.
A positive 4a. That's the only t squared there is, isn't there? Okay, cool. Positive 4a. I'm going to write that down. Positive 4a. And then here's a negative 6a. You guys agree with that? That's cool. There's only one of those to keep track of. That's not bad. Negative 6a right there. And then up top, what's up top?
2a.
A positive 2a of those. Now, check this out. What are those? Don't even look up here a second. How many of those guys we got over here on the right-hand side? How many are over here on this right-hand side?
0.
0. Okay. So that's a 0 from the right-hand side, and those are the coefficients from the left-hand side. Now, it turns out this ain't going to help me worth a lick. That's a technical math term, worth a lick. It ain't going to help me. What do I get here? Well, what I do get is ultimate truth. That's kind of nice. Ultimate truth. 0 does equal 0.
That's nice to know.
I mean, if you got a 6 equals 0, then you might start freaking out. What did I do wrong? What happened? So this is interesting. Analyzing some of these terms doesn't help. But it doesn't help. That didn't help at all. But it did confirm ultimate truth, which I appreciate every once in a while in my life. Hey, let's look for the e to the negative 2t's then. Let's look at those guys. By the way, over on the right-hand side, how many of those do we have over on the right-hand side? 0 of those. But on the left-hand side, we play the game where we look for all these things. Here we go. Just the plain e to the negative 2t's. I guess, here's one, negative 2b.
That's it.
Well, I got this down here too. Here's another negative 2b.
There's a negative 2a.
And there's a positive 2a.
That's right.
So hang on, I just found a 2a and a negative 4b from that second derivative. That all came from that second derivative. Okay. Plus 3 of these guys. Okay, I'm looking for the e to the negative 2t's. Look, I think I see a 3b. I guess that's it, huh? A 3b. All right, a 3b. And then up here, look up here. There is nothing up here. There's none of those guys. None of those plain, constant e to the negative. All right, well, here we are. This ain't bad. 2a minus b, if I collect a couple like terms, equals 0. That's kind of cool. Listen, thankfully, we already know a. And since we already know a, we can plug it in there, and we can get b. So since a is a negative 4, a is a negative 2, that would be negative 4. You move it over, negative b would equal 4, or, okay, b is negative 4, I think. Whew, we're finally finished.
Unless you want to write the answer.
Yeah, which you should do. But after all that, nobody wants to write the answer, right? Yeah, don't do that. Don't be too lazy not to write the answer. We just found YP. And YP it's this YP right here is what it was. Not with the 2, but just here. The A is a negative 2, t squared. And then the B is a negative 4t, all times e to the negative 2t. And that's just the YP. Technically, that's the YP. That's the YC. And you should really write your answer Y. Here we go. All right, we're done. Now, at the end, I want to just double check, is there any dependency? This is a constant e to the negative 2t. this is a t e to the negative 2t, and this is a t squared e to, no, they're all different terms. There is no dependency. There shouldn't have been. We fixed that way back at the beginning. We had to adjust this YP because of dependency on the YC. That's, yeah. Yes, sir.
When we're generalizing the answer for YP in the very beginning,
yes.
Is it set that when we have an e function, it's the power that's with the e function on the right is the one we have to keep? Because we could.
Yes. So we're not generalizing this. I think is that what you were saying? The power on the e function is not getting generalized. So if it's an e to the negative 2t, it's an e to the negative 2t. Okay. The coefficient in front is being generalized. If it was just a 4, we would just have an a, e to the negative 2t.
So if it was
then we might have to adjust it. But what we had was a linear, I had to generalize that and call it a linear function times e to the negative 2t. So I made a general linear function. Then the extra t came in from the dependency, right?
Okay.
Yeah. Yeah.
So if we had like t squared, it would first be a t squared plus bt plus c.
That's what it would be.
You might have to multiply
at
by
first.
Or something.
Yes.
Okay.
That's the game. Yep. In your book, there's a page that with a table sort of that sort of runs through all these maybe not all of them, but examples of how to guess your YP. And they've got some good examples in sort of in a table format that might help. So we're done. There's the answer. Hey, you could make this problem a little worse, I suppose, if you had some initial conditions, because then you're not quite finished yet. I mean, if you had some initial conditions, you know, I want to say something. If you had some initial conditions like y of 0 equals 1, y prime of 0 equals 0. So what would you do now? If I'm just adding those here at the end. Maybe I want to do this, maybe I don't want to do this. But what would you do?
Take the derivative, and then you plug in y 0 equals 1 for the first, that function right there, and then you plug in 0, 0 for the derivative.
Yeah. So, I mean, these two initial conditions are to help me find, now they'll find C1 and C2, right? So, but here's and you guys are smart, I know but you apply the initial conditions to y, right? Look, they're about y. So you might be tempted to try to apply them back here. Oh, I'll just use them back here to find C1 and C2, but hold on, this ain't y, is it? Okay, so you gotta wait till you get to the end. You can't apply the initial conditions to half your answer. This YC is not y. So you apply the initial conditions to y, which means you gotta wait till you get to the end of the problem, and we could try to apply these initial conditions and see what happens. Let's try it, see what happens. Go ahead.
Can we apply the first one and then take the derivative, or does that not work like that?
Well, so the initial conditions are about plugging a 0 into y and getting a 1, plugging a 0 into y prime and getting a 0, and that means we need y, not yc.
Yeah.
Yeah. So we need y, which involves all this crap, which might, I don't know if that's gonna, when you plug zeros in there, that's just gonna go away anyway. But I do need the damn derivative. Yeah, there, let's just do this at the end and see what happens here. So at the end, I'm gonna make this extra move here. Like y'all, it's real easy. That first initial condition is pretty easy. You plug in a 0 and this y value is 1. So when I do that, I plug in a 0, I get e to the 0, I get C1 plus C2. And you're saying when I plug in a 0 over here, that's all just gone. Right, okay. So there's a true fact. Now, you can't find C1 and C2 with that alone. That's why there's that other condition, that other initial condition. But But that other initial condition makes me, I need y prime. Let's do it. I'll do it right down here on the bottom, I think. Y prime is negative 2c1 e to the negative 2t minus c2 e to the negative t. That's the chain rule, spitting out a couple of things there. And then I got to do this product rule, I guess. The derivative of the first, negative 4t minus 4 times e to the negative 2t plus negative 2t squared minus 4t. I'm writing that down. And then I need the derivative of that e. That would be a negative 2 e to the negative 2t. Wow. This is some hard work, boy.
Good thing it's 0.
I mean, 4-4, everything just got tougher in 4-4 because you got all this YP action. I mean, that took half an hour on that, just for that YP stuff. So, anyway, if I throw I don't want to clean this up. I just want to I want to throw my initial condition in here that says if you plug in a 0, you'll get a 0. All right, so I'm going to get a 0 for y prime, and if I plug in a 0, I get negative 2c1. Thank you, sir. That's fine. That's okay. Thank you very much. Negative 2c1, negative c2. What else, though? There might be something else here. If you plug in a 0.
That's it. No, minus 4.
If I plug in a 0 over here, all that's gone, right? That's a big 0. But right here, you're right. That's e to the 0, which is a 1. That's a 0, but that's a negative 4. I guess I get a little negative 4 there. Woohoo! All right, now I'm solving these little 2 equations, 2 unknowns. I'll get C1 and C2. How would y'all do this? You know what I think I'll do? I think I'll just add these equations. I'm going to add these equations. You ready? If I add this, I think that's a 1. If I add this, I think that's a negative C1. If I add this, they're gone. And if I add this, it's a negative 4. Normally you don't do that. Normally that's on the other side, but that's okay. We'll move it to the other side now, and we'll have a 5 equals negative C1, or C1 is negative 5. If C1 is negative 5, yeah, I'll plug it right in there. 1 equals negative 5 plus C2. I guess C2 is a 6. Wow. So now I got a specific answer. It's right here. I'm not going to even write this one though, but it's right here with C1 being negative 5 and C2 being 6. Yeah. A specific, particular solution now. A general solution with those initial conditions. Now we got a particular solution. Yeah, that was fun. Let's try another one. Are there any other, let me think here, are there any other little subtleties going on? Let's see. All right, how about this? You know, when I put that 4 in parentheses, you know what that means, right?
It's just the word before.
Derivative.
Yeah, it's the 4th derivative, yeah.
I thought IV was.
Well, that's one way. Right, this is another way.
Oh,
So the 4, you know, a 4 without parentheses is an exponent 4, you're right.
Okay.
But with the parentheses, that little 4 is a derivative 4. It's the 4th derivative.
Thank you for telling me.
I know, I'm glad I told you, right. So that's the 4th derivative, that's the 2nd derivative. And now I want to say it equals, right, 3x squared. Okay, so this time I'm using x instead of t. It's probably confusing, but I'm sorry. All right, I want to do it. I want to find the YC. I find the YC by pretending it's homogeneous. I pretended now it is a power, m to the 4th plus m squared equals 0. And I'm factoring, yep. Try to find those roots.
We have 2 zeros
Okay, good.
and something else. Square root of 1, negative 1. We have i's.
Perhaps.
Yeah. Square root. Yeah.
Yeah, you're right. You factor out an m squared. I mean, sometimes students get lost in this algebra, and it's bad to you don't want to ruin this problem too soon. At least you want to get somewhere before you make a mistake. So, but making a mistake early, right, costs you more points, I suppose. But try not to. Right, here we go. If I set this m squared equal to 0, what I'm getting is m equals 0, and it's a repeated root. Do you agree? It's a repeated root. It has multiplicity 2. There's 2 of those zeros, right? And then the other one is a m squared plus 1, and then if you move the 1 over, it's m squared equals negative 1, and it is good old plus and minus I. So there's 2 roots, and there's 2 roots. I was kind of looking for 4 roots. And I can write my answer. My answer for the YC, but you kind of got to remember how to write your answer. But first of all, for the 0, it's e to the 0x, which it's c1 e to the 0x, which is just c1. And then he's repeated, so it's c2 x e to the 0x. That's how you handle. But that's so there you go. That's how you handle that repeated 0. And then we have the 0 plus or minus I, and that was an e to the 0x times c1 1x and plus c1 cosine x and c2 sine x. You remember that?
Yeah.
Oh, and I shouldn't say c1 and c2. I'm sorry. I should say
C3, C4.
c3 cosine x and c4 sine x. That's from the 1i.
Yeah.
Out in front of this is an e to the 0x. That's from the 0, but that's just a 1. Wow, there's your YC. Any questions? I'm assuming you knew some stuff there, and you seem to follow me, I guess. I think you're still thinking. Listen, one more time. My notes were, when I have alpha plus or minus beta I, what I had was e to the alpha t or x, c1 cosine beta t, c2 sine beta t. So that's what I just did, you guys, with the 0 plus or minus 1i. That's what we just did. All right, well, I'm ready to make my guess for my YP. Okay, that has nothing to do with it. I need my guess for my YP. My YP looks like a quadratic function. You know how to guess a quadratic function. How about ax squared plus bx plus c? I mean, you got to make a general quadratic. And so that's awesome. Now, maybe I'm ready to go do my derivatives and all. Oh shit, I need 4 derivatives. But hold on a second.
What about
You always got to stop and check for dependency. That's right. That's the new thing. It's not a new thing, but I didn't tell it to you last week. You got to stop and check for dependency. You're right. And is there any dependency?
yes?
There sure is. You got a constant sitting here, and you got a constant sitting here. So you adjust him by multiplying by x. But you don't just multiply him by x. You multiply this whole thing by x. So now it's an x and an x squared and an x cubed. You guys okay? Okay, good. We solved our dependency problem?
No.
Oh shit, no we didn't. Because here's another constant times x.
Just do another.
So I need another x. And I need it by the whole thing. Yeah, you're right. So now this is an x squared, this is an x cubed, and this is x to the 4th. It was a quadratic equation is what it was, but we had to adjust it twice for the dependency. It had dependency on these terms. We had dependency on these terms, And so we adjusted it. Adjust, I'm going to say this again, adjust YP for dependency on these terms. Dependency. Hey, at least we don't have any product rules this time. But I do got to do 4 derivatives. Y prime. It is kind of fun. These are easiest derivatives there are. These are the easiest derivatives there are. There's a Y prime. What's funny is I don't even need Y prime. I need Y double prime and I need Y fourple prime. Let's get Y double prime. 12a x squared, 6bx, 2c. Yes? And that's the one I need. Let's see, Y triple prime. 24ax, 6b. But I really need Y fourple prime. Y fourple prime is 24a. And this is what I need. I need one of those. Is that what I need? One of those and one of those. That's what my right hand side, that's what my left hand side is. One of those and one of those. I'll plug them in and I'll equate it to the right hand side. And if I'm going to equate it, there's different terms I can look for. I can look for, I'm equating the coefficients of the x squared. I'm going to write that. This is what I'm doing. I'm equating the coefficients of the right-hand side to the left-hand side. And I look at all the different terms. So I can do it to the x squareds, I can do it to the x's, and I can do it to the plain old numbers. Right, you guys? I don't know how many of those I need to do, but that's, I can look at the coefficients of all those types of terms. Okay, let's find the x squareds. Let's see, now wait a minute. I'm plugging this in. This one I could actually plug in, but what I have is I have one of those, and I have one of those. So where's all the x squares? I guess I got, there they are. 12a. I guess 12a has to equal 3. Has to, huh? Has to. So I've already got a. By the way, I'm looking, what am I looking for? I guess I'm looking for an A, B, and a C, ultimately. You know, this is my original YP. I need an A, B, and a C. Anyway, we just got A. What's A? 1/4? 1/4. Awesome. All right, let's look for the X's. All the X's. Any X's here? No.
6b.
Just 6b. Okay. So 6b has to equal 0. There is no X's up here on the right-hand side. See, remember, you're plugging this in. This is going in up there. This is going in up there. This is your right-hand side, left-hand side. And you're equating it to the right-hand side. And 6b has to equal 0. So guess what? B is 0. That's awesome. Let's look for the plain old numbers. What about plain old numbers? I guess I got a 24a and a 2c. And they have to add up to be 0. But that doesn't mean C is 0 or A is 0. We're gonna find a C this time. We already know A is 1/4. So if I plug in that 1/4, this becomes a 6. 1/4, that becomes a 6, plus 2C equals 0. 2C is -6. Good old C is a -3. Woohoo! We're done. We found YP. Wow. So the YP is, where was it? This is what it was. This was my original YP. So A is a 1/4 x to the 4th.
Or minus 3x squared.
Well, the B was a 0. So that's gone. And then you're saying -3x squared. I got you. -3x squared. Okay, there it is. Well, there's your YC, there's your YP. Your answer is all that added together. And then I kind of want to look at it when it's all done. Is there any dependency? There shouldn't be. We tried, we adjusted this guy so there wouldn't be any dependency, and there's not.
If there is dependency at the very end, how do you fix that?
Well, there shouldn't be. It means you screwed up at the beginning.
Okay.
There shouldn't be.
Start over.
Yeah.
Oh, that'll be fun.
Yeah. Something happened with your guess, I guess. All right. This is hard work. I got more on my mind, though. Let's keep working a little bit here. Here's another one. So here's just a brand new problem here. This really isn't too bad. This will be a little nicer, but this will be a little bit nicer, I think. Here we go. You know how to start. You start by m squared plus 9 equals 0. You're pretending it's homogeneous. You're looking at the auxiliary equation. You're finding the roots. The roots are plus or minus 3i. You guys see that? When you move the 9 over. So I found my roots. They're imaginary. It's 0 plus or minus 3i. I know how to write that. My YC is
C1 cosine
3t. I'm using t or x. It doesn't matter. C2 sine 3t. Okay, good. That's how you do it. That's the kind of answer you get. Okay. Now I should make a guess for my YP.
cosine 2t.
And my guess is sort of a generalized version of this. And this brings up maybe another new topic. Here's your guess, you guys. It's A cosine 2t plus B sine 2t. The general guess for a cosine or a sine or a cosine plus a sine is you got to guess both. You're guessing both. I mean, and I know you're looking at, there's just a cosine up there, and by the way, but I have to guess a cosine and a sine, and it's because of their derivatives. I mean, keep in mind what you're doing. You're guessing a solution for y, and you're going to take derivatives of y, and they're going to go in here, and you know, so a second derivative and an original function, and I mean, you might have cosines and sines in here. I don't know. It's just possible to have. So you guess cosines and sines for a cosine or for a sine or for both. Now wait a minute. There is something specific about this. Am I guessing any old cosine? No, I am guessing a cos 2t, right? The argument of the function, the angle of the function is specific. It's a 2t. It's a sine 2t. But the coefficient is some constant in front. Hey, is there dependency? Well, these are cosines and sines, these are cosines and sines, but they are different. With the cosine 3t and the sine 3t, they're different. They're not dependent on 2t's. They're different functions. Cosine 3t, sine 3t are linearly independent from cosine 2t, sine 2t. They are. Somehow we should have learned that in 4.1, I guess. Okay, so there's no dependency. That's my guess, and I guess I could keep going here, right? It's not too hard. Again, no product rules, luckily. Y prime.
Y prime? How to be a negative 2a sine 2t?
Yep. Must be teaching
Y prime, the derivative of cos, the derivative of cos is
Negative
negative.
sine 2t.
Negative 2a sine 2t
Plus
2b
2b cos 2t. All right, now another derivative, y double prime, please.
Negative 4a cosine 2t.
Negative 4a cosine 2t
Minus 4b sine 2t.
minus 4b sine 2t. Right? You guys are right. That's what you got to do. And then I'm trying to plug these in. What I'd rather do is sort of this. This is my little shorthand. I say, when I plug this y double prime in, I say I got one of those plus 9 of those original y's. There's the original y, so there's 9 of those. These are multiplied, and it has to equal the right-hand side. So I start, and what I can look at what I'm looking for. Then is the terms. I'm looking for the cos 2t terms. I might take a look at the sine 2t terms and see what I can come up with here, and try to find my unknown coefficients a and b.
Oh.
Let's see.
Cos equals 3.
So if I'm looking for the cosines, then I got negative 4a. Is that what I got? I got negative 4a and 9a. And it has to equal 3. Oh, yeah. Negative 4a plus 9a has to equal 3. Is that what we're saying? Okay. Well, that's not bad. So that's a 5a has to equal 3. I guess a is 3/5. I guess b might be 0 here. Let's see what happens. I got this. If I look at the signs, I got a negative 4b. And then I got 9b, but they do have to add up to be 0. So I'm going to have 5b equals 0, and so b is 0. You know, that doesn't always happen. I mean, don't bank on that. You know, yeah, there's times when what you got is a cosine function, but your YP turns out to be a sine function, or both. I mean, in this case, the b was a 0, and the a was 3/5, so there was a cos on the right-hand side, and our YP ended up being a cos. Our YP is 3/5 cosine 2t, huh? That's it. We're done. The answer is all that. Y equals all that. This is good stuff. I'm not going to do too much more. In fact, I might want to leave just a little early today. I got a little bit of business to take care of. But I do want to do something else here for a second. Let's just pretend we're doing this game where we're guessing. So what if you had an x squared sine 3x? If this was your right-hand side, what would be your guess?
X squared plus c.
So an ax squared plus bx plus c
And then parentheses.
sine 3x
Plus cosine.
plus, holy shit,
Well, plus ax squared plus bx plus c cosine.
how about dx squared plus ex plus f cosine 3x?
So we can't have ax squared plus bx plus c, and then in parentheses sine 3x plus cosine 3x.
Well, no.
No. Okay.
So like this one, what was this one? This was a constant times a cosine function. So our guess was a constant times a cosine and then a different constant times a sine. Well, when that constant's a linear function, then I need 2 little linear functions right there. And if it's a quadratic function, I need 2 quadratic functions right there. Yeah. Wow.
Wow. That's a fun test question.
Yeah, we won't actually do one like that, but it sort of helps sink in here. By the way, you know, I only have guesses for sort of nice functions. if I had a right-hand side that was a tangent function, this method doesn't work. I need a new method. I need to go up to 4.6 or somewhere else. It doesn't work because there's no pattern. See, it's the fact that sine and cosine are derivatives of each other that give us the pattern for guessing sines and cosines. And the fact that e is his own derivatives gives us a pattern for guessing e functions. And we know how to guess polynomial functions. But we can't guess, we don't have a guessing method for tangent. There's no pattern to his derivatives. So I can't do everything. I can do sines and cosines, e's, and polynomials, I guess. Oh yeah, yeah. Here, I better do one more. I forgot about this one. I better do one more here. 4y, I'm making one up here. 4y double prime minus 3y prime equals 3t squared plus cos t. Oh man. Plus e to the 3/4 t. Wow, you guys. Let's do this problem. Maybe. I might quit halfway through. All right, let's try this problem. I got a hell of a right-hand side. See, this is what's new now in this problem. This is new. Is that I kind of have what my right-hand side is almost 3 separate little YPs. It's kind of a Y, you can go subscript crazy here, but I'm going to have kind of a YP1, a YP2, and a YP3. I mean, I kind of got 3 separate little YPs, but then I join it all together. I just add them together and call it one big YP. But it's kind of, there's 3 separate little things going on here. You haven't really seen that yet in any of my examples. Now, first though, we start off by trying to find the YC. We need to start there. So we got the 4m squared minus the 3m equals 0, right you guys? You factor out your m and you got 4m minus 3 equals 0. You get your roots, 0 and 3/4, I guess, huh? And so you can write your YC as C1 e to the 0t. That's how you do it. And then C2 e to the 3/4 t. It's cool, you know, you can do that first part. You get, that should be half the credit, shouldn't it? I don't know about that. But, I mean, it's sort of half the problem. Not exactly. But now, my guess for my YP. So my guess for my YP is sort of made up of 3 little YPs, like I said. I think the first would be a quadratic. I think I should guess AT squared plus BT plus C. Thank you. Next comes a cosine function. And the way to guess a cosine function would be a D cos t, and then an E sine t. I mean, that's how you have to do it. Yep. You have to do that. And then you have your E function. When it's just a constant times an E, so just a F E to the 3/4 t. Right. So now, do we have dependency? And I think we got two different dependencies. Thank you. This is interesting. Now watch this. So you might have learned so far today that if you have dependency, you got to multiply the whole thing by t. But when you have these 3 separate YPs, you don't multiply the whole thing by t, just the one YP that was affected. Now, anyway, so you're saying there's dependency on this term to this term. That's dependency. So you have to multiply him by a t. See, the reason you have to multiply his whole thing by t, though, is because as soon as you multiply by t, it's dependent on him. So then you multiply him by t, which is then dependent on him. So you multiply him. So you do kind of group this together and multiply the whole damn thing by t. So it turns out to be at cubed and bt squared and ct. But you don't have, there's no reason for you to multiply any of those by t. There is not. See, this is in this world where we have these three separate YPs. You do sort of treat them separately for this when it comes to this interference issue. But you said there was dependency here, right? There's dependency here. There sure is. A constant times an e to the 3/4 t. That's a constant. Yeah. How do you change him?
You just add or t, sorry.
Yep. Look at this. ft e to the. It sounds like, it looks like I'm spelling a word here.
More letters than numbers.
That's right. More letters than numbers. Right. You're right, though. So here's your. This is your. And then what's dangerous, after you adjust it, you write down your original YP, and then you make your adjustments, and then you go get to work. It's probably a smart idea. Then at the end, you find your ABC, and you don't want to go at the end, go fill your answers back in up here. Right, you guys? This is not your YP anymore. You might want to get rid of that sucker. I mean, this is your new adjusted YP right here. And if I want to actually do this problem, I would take a derivative. I would take a second derivative. I would try to add up all the coefficients, see what I can come up with. It probably isn't right. There is a little product rule at the end. I might quit though. This might be a good place to quit and let you finish it some if you're in your leisure. Hey, you've learned a lot here now. So anyway, catch up to me. 4-3, 4-4, 4-4 is kind of where it's at. Do some homework, answer me some questions, and I'll see you Thursday.